Hello students, I am Mrs.K.GLORY Prashanth, Assistant Professor, Department of Mathematics, SA Engineering College. So in the GATE syllabus, the topic of statistics typically includes 5 different subtopics. Each subtopic is discussed in 5 different sessions. In first session, we discuss about Z-test. In session 2, we discuss T-test. In session 3, we discuss F-test. In session 4, chi-square test for goodness of it. In session 4, chi-square test for independence of attributes. Before moving into the session, let us look into the testing of hypothesis and its basic terminologies. Testing of hypothesis. The theory of testing of hypothesis was initiated by J. Neyman and E.S. Pearson. It employs statistical techniques to arrive at decision in certain situations where there is an element of uncertainty on the basis of sample whose size is fixed in advance. Now let us move on to the terminologies. The first terminology is population. So what is meant by population? A population is a collection of objects or item which is either animate or inanimate under any statistical investigation. So you should know what is meant by animate and inanimate. So animate is nothing but living things and inanimate is nothing but non-living things. Animate is nothing but living things and inanimate is nothing but non-living things. Okay, so the population is nothing but a collection of objects which can be either an animate or inanimate. Now next one is sample. A small portion of the population is known as sample. In other words, a subset of the population is known as sample. The next terminology is parameter. The statistical constant that describes the characteristic of the population is known as parameter. Now let us see what is meant by statistical constants. You might have studied mean, median, mode, correlation, all these things, right? So that is known as statistical constants. When you compute that for the population, we call it as parameters. When you compute the same statistical constants, for the sample, we call that to be a statistic. Right? The next one is test of significance. So there are 2 tests of significance. The first one is the difference between the sample and the corresponding population parameter, and the second one is the difference between the 2 independent sample statistics. So these are the 2 tests of significance we perform in all the 5 sessions. A very important point to be noted. The next one is hypothesis. A hypothesis is nothing but an assumption or statement which may or may not be true about the population. So that is known as hypothesis. Now hypothesis is of 2 types. One is null hypothesis and another one is alternative hypothesis. Let us see what is meant by null hypothesis. Null hypothesis is a hypothesis which is tested for possible rejection under the assumption it is true, and it is denoted by H0. To be in simple, null hypothesis means there is no difference. Null means what? There is no difference, right? And the next one is alternative hypothesis. The complementary of null hypothesis is nothing but your alternative hypothesis. It is denoted by H1. The next terminology is test. There are 2 types of test. One is two-tailed test, another one is one-tailed test. So in two-tailed test is used when you want to determine if there is a significant effect on either direction. For example, let us consider a new drug suppose we wanted to test a new drug has a different effect compared to an existing drug. So let us consider an example whether the new drug has a different effect compared to an existing drug. So we are taking this as an example. Okay. Now, what would be the null hypothesis? So the null hypothesis is nothing but H naught from mu is equal to mu naught. What is the meaning of this? The parameter, this is your parameter. So the parameter is equal to a specific value. So this is the meaning of null hypothesis. Now next, what should be your alternative hypothesis? Alternative hypothesis, we know that it is represented by H1, and in alternative hypothesis we should have mu naught equal to mu naught. Okay, so what is the meaning of this? The parameter is not equal to a specific value, right? Now next one is one-tailed test. So one-tailed test is used to determine whether there is a significant effect in one direction, either towards the left or towards the right. Now let us move on to the example. Suppose you want to test if a new drug is more effective or less effective than an existing drug. So in such case, your null hypothesis will be the same. H naught from mu is equal to mu naught. That is, the parametric value has a specific value. The parameter has a specific value. Now what will be your alternative hypothesis? H1 from mu greater than mu naught, or is H1 from mu less than mu naught. So what is the meaning of greater than mu naught? It is nothing but a right-tailed test. So when do we use this term greater than? So when something like, if you are talking about maximum, superior, higher, we go for right-tailed test. When you talk about inferior, minimum, all these terms, lower, we go for left-tailed test. So this is known as left-tailed test and this is known as right-tailed test. Now next is types of error. Generally, when you collect a sample, there is a possibility of conducting two types of error. Okay, there is a possibility of committing two types of error. Okay, so the first one is type 1 error, which means that reject H naught when it is true, and the next error is type 2 error, accept H naught when it is false. Right? The probability of type 1 error is denoted by alpha. Probability of type 1 error is denoted by alpha. Okay, and the probability probability of type 2 error is denoted by beta. Okay, now this probability of type 1 error, which is equal to alpha, is known as the level of significance. Okay, so the level of significance is nothing but the maximum probability of committing type 1 error, right? So this is very important question. So they will ask in GATE exam. So type 1 error and type 2 error, very, very important question. The next, now let us move on to the session, first session, that is Z-test. What is meant by Z-test? Okay, a statistical test used to determine if there is a significant difference between the sample and the population means or proportions, or between two sample means or proportions. Especially if the sample size is greater than 30, a very important point to be noted. So the sample size greater than 30. Okay, and the population variance is known. So because of this sample size greater than 30, we call Z-test as last sample test. Okay, so Z-test is otherwise said to be a last sample test because the sample size is always greater than 30. Now next one is assumptions of Z test. The first assumption is normality. So what is meant by normality? Normality means the population from which the sample is drawn should follow normal distribution. So that is the meaning of normality. The second assumption is independent. What is meant by independent? The sample from which the population is drawn should be independent to each other, which means the selection of one observation should not influence the other observation. Next is known population variance. So to apply Z test, definitely the population variance must be known. If it is not known, then you have to increase your sample size, right? The next one is scale of measurement. So scale of measurement is of 4 types. One is nominal, ordinal, interval, ratio and ratio. So 4 types are there: nominal, ordinal, interval and ratio. So here to apply Z test, we should either go for interval, or ratio. Interval or ratio, right? Now next one is random sampling. So what is meant by random sampling? Again, the population from which the sample is drawn should be randomly selected. Okay, so that is known as random sampling. Very important, these 5 assumptions should be satisfied. So what are the assumptions of Z test? Normality, independence, the next one is known population variance, and the next is scale of measurement and random sampling. These 5 assumptions has to be satisfied. So only when it is satisfied you can go for Z test. If any of these assumptions are violated, then you should go for other test, for example T test, which might be most appropriate. The next is applications of Z test. There are 4 applications of Z test. The first one is test of significance of single mean. The next one is test of significance of equality of 2 means. Next one is test of significance of single proportion, and the last one is test of significance of equality of 2 proportions. So first one is test of significance of single means. So the test statistic is very, very important to solve a problem. You have to memorize, no other go, right? So for each application you have a test statistics, so which has to be memorized. So test of significance of single mean, your test statistic is Z is equal to x bar minus mu divided by sigma by root 10, which follows, this is known as follows, right? Follows normal with mean 0. This is nothing but, we call this as follows. Follows normal. This is normal distribution with mean 0 and variance, with mean 0 and standard deviation 1. So now here, what is your x bar? It is nothing but sample mean, mu is population mean, sigma is population standard deviation, and n is nothing but sample size. Sometimes instead of population standard deviation, they will give even sample standard deviation also. Sample standard deviation, so which is represented by S. So in the formula, in the place of sigma, suppose your population standard deviation is not given, instead of that sample standard deviation is given, you have to substitute, you have to replace sigma by S. Okay. Now next is test of significance of equality of 2 means. The test statistic is given by Z is equal to x1 bar minus x2 bar divided by square root of s1 square by n1 plus s2 square by n2 follows again normal 0, 1. Here x1 bar and x2 bar are sample means, s1 square and s2 square are sample standard variance. Okay. Next one is n1 and n2 are sample sizes. The next is test of significance of single proportion. So in this, the test statistic is Z is equal to small p minus capital P divided by square root of capital PQ divided by N. This also follows normal distribution with mean 0 and standard deviation 1 and variance 1. So here small p is nothing but sample proportion, capital P is population proportion, Q is 1 minus p, and N is nothing but your sample size. The next is test of significance of equality of two proportions. So here the sample, the test statistic is Z is equal to P1 minus P2 divided by square root of PQ into 1 by N1 plus 1 by N2. So here P1 and P2 are nothing but sample proportions. Capital P is nothing but population proportion, which is nothing but N1 P1 plus N2 P2 divided by N1 plus N2, and your capital P is nothing but 1 minus Q. So Q is nothing but obviously 1 minus P, and your N1 and N2 are nothing but your sample size. So all these test statistics you have to remember, you have to memorize. See, this is a test of significance of single mean. So this is your test statistics which you have to memorize. So this one you have to memorize. Z is equal to x bar minus mu divided by sigma by root n. And the next, the test statistics is nothing but Z is equal to x1 bar minus x2 bar divided by square root of s1 square by n1 plus s2 square by n2. The next test statistic is single proportion. For that, Z is equal to small p minus capital P divided by square root of PQ by N. And for equality of two proportions, you have to remember the test statistics. Z is equal to P1 minus P2 divided by square root of PQ 1 by N1 plus 1 by N2. So you have to remember this. Now next, table value. So very important, here table value for Z test you can memorize. Usually they'll ask 1% and 5% to solve a problem. So you can memorize this. If you look at the table for two-tailed test, the value of the level of significance for 1% is 2.58 and for 5% is 1.96. For left-tailed test, the value of the level of significance for 1% is minus 2.33 and for 5% is 1.645. And for the next right-tailed test, the level of significance, the value of the level of significance for 1% is 2.33 and for 5% is 1.645. Now, a very important is the procedure for testing of hypothesis, a very important concept. Again, this concept is applied in all the sessions to solve the problems. These are the steps which should apply for all the tests to solve a problem. Now let us see one by one. For the procedure for testing of hypothesis has 5 steps. The first step is state the hypothesis. What is meant by state the hypothesis? What do we do in state the hypothesis? Here we will mention the null hypothesis and alternative hypothesis, that is nothing but H naught. Okay, so in state the hypothesis, what should you do? You should mention your null hypothesis as well as your alternative hypothesis. Next one is select the criteria for a decision. What is meant by select the criteria for a decision? You should fix your alpha, whether it is 1% or 5%, that has to be fixed in the second step. The third step is you have to collect the sample data. After collecting the sample data, you have to perform the test statistics. See, we saw 4 test statistics. So you have to apply that formula and you have to compute the test statistics. The next one is you have to calculate the table value. Just now we saw the table value, how to calculate for different tests, that is two-tailed test, left-tailed test, right-tailed test, and for different level of significance, right? So that you have to do it. So after finding this, a very important step is making a decision. How do you make a decision? So the decision is made based on the step 3 and step 4. So this after computing the test statistic, we call the test statistics as calculated value. Calculated value. This is otherwise said to be Z statistic. Okay, so this compute the test statistics. What does it imply? How do you call it? After computing the test statistics, we can call it as calculated value, or else you can call it as Z statistic, right? Now, the table value you are getting from the table. Now what you have to do is you have to compare the calculated value with the table value. Suppose your calculated value, very important point to be noted, is less than the table value. Okay, if your calculated value is less than the table value, then you have to accept H0. Otherwise, vice versa, if your calculated value is greater than the table value, in such case you will reject your H0. So this is very, very important. So based on this, you will make a conclusion. Suppose your calculated value is less than the table value, what you will do? You will accept your null hypothesis, or else what you will do? You will reject your null hypothesis. That is, if the calculated value is greater than the table value, in such case you will reject your null hypothesis. So vice versa, right? So very important. So procedure for testing of hypothesis, there are 5 steps. The first step is state the hypothesis. The second one is set the criteria for a decision. Next one is collect the sample data and compute the test statistics. The next one is calculate the table value, and at last make a decision. So these are the 5 important steps to perform in all the sessions. These are the 5 steps which is performed in all the sessions. Now next. Now let us solve few problems from GATE questions, from GATE examination question paper. Okay. Now the first one is, what is type 1 error and type 2 error? So you know what is, just now we saw in the basic terminology type 1 error. What is type 1 error? Reject H0 when it is true. So where is reject H0? Reject H0 is here. Even reject H0 is here. Remaining 2 places we have accept. So reject H0, reject. So any of these 2 options it will be, right? Now let us check the remaining one. Reject H0 when it is true. Okay, when it is true. In both the cases, no. In type 1 error is different and type 2 error is different. So type 1 error is reject H0 when it is true. And what is your type 2 error? Accept H0 when it is false. So which one is correct? The second one is correct. So not the first one. So what is meant by type 1 error? Type 1 error is nothing but reject H0 when it is true. And what is your type 2 error? Accept H0 when it is false. So your correct option is B. Now next. Second question is, the null hypothesis will be rejected, and the null hypothesis will be rejected when H0 from mu is equal to 14 versus H1 from mu greater than 14 and alpha is equal to 0.01 if the Z value is greater than. See what is given in the question. First you have to recollect it. See what and all is given to us in the question. First they are talking about null hypothesis. So you need not have to frame the null hypothesis. Already it is framed in the question. So this is your null hypothesis. And what is your alternative hypothesis? Mu greater than 14. So your step 1 is over. Already it is given. They have given the null hypothesis. They have given the alternative hypothesis. So the stating the hypothesis is over. Now next step is you have to select the criteria for a decision. What the criteria is also given to us, that is the level of significance. It is 0.01, which means that it is 1%. right? The next one is, yeah, so these are the information given to us. Now what they wanted us to do, they are asking us when will this H naught is rejected. When do you reject H naught? Just now we saw, when do we reject our H naught? When your calculated value, when your calculated, that is the test statistics, when your calculated value is greater than the table value. So in such case, what you will do is, you will reject your H naught. Now what they are telling, they have given us H naught, null hypothesis, they have given alternative hypothesis, they have given the level of significance, and they have said even you are rejecting your null hypothesis. So which means that your calculated value should be greater than the table value. Now if it is 1%, see, you got 1%, and here what it is right-tailed test, because greater than, so we got right-tailed test, the level of significance is 1%. So what is the value we saw in the table, right? So in the table for 1% right-tailed test, it is 2.33. So your table value is 2.33. So what is the meaning of it? Now calculated value is not known to us because the data are not given to us. Sufficient data is not given to calculate the test statistics. So it is not available, so we are not calculating. But they have given the statement, the Z value is greater. So greater than what? 2.33. So what is the answer here? It is 2.33. Please understand the problem. Here you need not have to calculate the test statistics. So everything is given to us. Null hypothesis is given, alternative hypothesis is given, level of significance is given to you, and they have even said your null hypothesis is rejected. So when null hypothesis is rejected, obviously calculated value will be greater than the table value. Okay, when you reject your null hypothesis, calculated value will be greater than the table value. So they have asked Z value greater than, this is your Z value, this Z value should be greater than 2.33. Only then you can reject your null hypothesis. For a test in the null hypothesis H naught from mu is equal to 10 and the alternative hypothesis H1 from mu greater than 10 at alpha is equal to 0.05 level, the sample mean is 9.75 and the sample standard deviation is 2, where sample size n is equal to 100. What is the correct conclusion? Now this is a problem given to us. So first pick out what is given in the question. What they have given is null hypothesis. So the null hypothesis, that is your step 1. Step 1, your null hypothesis is H naught from mu is equal to 10. Okay, this is given to us, and then your alternative hypothesis is also given, H1 from mu greater than 10. So which means that this is one-tailed test. Why? Because we have greater than 10. The next is, second step is, you have to fix your criteria, and they have given in the question it as alpha is equal to 0.05. Now next what you have to do is you have to compute the test statistics. To compute the test statistics, the data given is sample mean, which is nothing but x bar is equal to 9.75. And your sample standard deviation, which is represented by S, sample standard deviation which is represented by S is equal to 2. And the sample size given to us is 100. So n is equal to 100. And your mu is already given. It is stated in the hypothesis. Mu is equal to 10. So now let us compute the test statistics. So your test statistic is Z is equal to X bar minus mu divided by S by root n. Okay, let us substitute the values. 9.75 minus, your mu is nothing but 10, the whole divided by 2 divided by square root of 100. So 9.75 minus 10 is nothing but 0.25 minus 0.25 divided by 2 divided by 10, which is nothing but 0.2, so which is nothing but minus 1.25. So this is your test statistics. So your test statistic is minus 1.25. So now what you have to do, you have to take modulus since it is a negative value. So modulus of Z is 1.25. Now the fourth step is table value. So here what did they give us? They have given alpha to be 5%, and we know from alternative hypothesis it is a one-tailed test, that is it is a right-tailed test. So your table value for 5% right-tailed test is 1.645. Now your fifth step is making a decision. So let us make a decision. So what you have to do here is you have to compare your calculated value with the tabulated value. Okay, so that is with the table value. So your calculated value is 1.25 and your table value is 1.645. Which is greater? Your table value is greater. So which means that what you do here, we are accepting our H naught. So your correct option is accept H naught. So this is your correct option. Now let us move on to the next. The next question is, a company claims that the average life of its LED bulb is 1200 hours. A random sample of 40 bulbs is tested and the sample mean life is found to be 1180 hours. The population standard deviation sigma is known to be 60 hours. Calculate the test statistics. Now we will find the test statistics for this. Now if you look at this problem, what is given to us? The average, a company claims that the average life of its LED bulb is 1200. So what is given to us? Mu is equal to, they have given mu is equal to 1200. Okay. The next, a random sample of 40 bulbs. What is meant by random sample? It is nothing but n is equal to 40 and the sample mean is found to be, what is our sample mean? X bar, which is nothing but sample mean is 1180, right? And your population standard deviation. So population standard deviation is given, which is nothing but sigma is equal to 60. Now let us move on to the Z test. Okay, so the test statistic is Z is equal to X bar minus mu divided by S by root n. So what is your X bar? 1180 minus 1200 divided by S. S is nothing, instead of S they have given sigma. So what you do is, here you can take instead of yes, you can take it as sigma, right? So 60 divided by square root of 40. Okay, so the answer for this is minus 2.11. So when you calculate it, you will get the answer to be minus 2.11, which is nothing but your Z statistics. The next question is, two factory produces same type of light bulbs. The factory A claims that the mean life of their bulb is higher than the factory B. Okay, so first is there what you have to do is you have to pick out what is there in the question. You are considering two factories, so factory A and factory B we are comparing. So let us consider the factory A as factory A as mu1 greater than mu2, right? So what you are doing is you are considering two factories. Factory A claims that the mean lifespan of their bulb is higher than that of the mean lifespan of the factory B. So this is what their consideration. So here your H naught is mu is equal to mu1 is equal to mu2, okay, and your H1 is mu1 greater than mu2. So this is your step 1. So step 1, you are setting your null hypothesis and the alternative hypothesis. So H naught from mu1 is equal to mu1 represents factory A and mu2 represents factory B. So mu1 is nothing but mean lifespan of factory A, mu2 is nothing but mean lifespan of factory B. So H1 is nothing but your alternative hypothesis. So here what is the statement given? The mean lifespan of bulb produced by factory A is greater than that of factory B. Okay, now next one is we have to fix our level of significance. They have given us in the question alpha is equal to 5%. Now, so next you see first statement we have written, for the first two sentence we have written. Now next sentence is a sample of 50 bulbs from the factory A has an average lifespan of 1300 hours with a standard deviation of 100 hours, right? So what is being said? X1 bar is equal to, what is our X1 bar? Step 3. This is our step 3. They collected the sample and they have calculated for A bulb, for the bulb produced by factory A. For that your mean is nothing but 1300 and your N1 is nothing but 50, right? And your standard deviation is nothing but what? 100. For factory B, the mean life span is 1250. Your N2 is here 60 and your sample standard deviation is 120. Now you move on to the test statistics. Because we are talking about two samples here, we have to go for test of significance of equality of two means. So we'll move on to that. X1 bar. So X1 bar is 1300 minus X2 bar is 1250 divided by S1 square. What is your S1 square? 100 square divided by your N1 50 plus S2 square. This is S2. S2 square is 120 square divided by 60. The answer for this is 2.38. Okay. So now this is your step 3. Now what is your step 4? Your step 4 is nothing but table value. So for 5% right-tailed test, your table value is right-tailed test for 5% it is 1.645. Okay, so now you are going to take a decision. Your calculated value is nothing but 2.48, which is greater than 1.645. So your calculated value is greater than the table value. So which means that you are rejecting your null hypothesis. Now next question is, a factory claims that 70% of its products pass quality control. A random sample of 100 products is taken and it is found that 65 of them pass quality control. At a 5% significant level, test whether the actual proportion of products passing quality control is different from 70%. What is the appropriate conclusion? So here something like we are not talking about means, standard deviation, variance. So we are talking about only the proportions. So if you look at this problem, what did they give? What is given is 70% of the product pass quality control, which means that so 70%, which means that capital P is equal to 70%. So 70 divided by 100, which is equal to 0.7, right? And your small p is nothing but 65 divided by 100. So they have said it is found that 65% of them pass quality control, so which is nothing but 0.65. Now what is your Q? Q is nothing but 1 minus P. So 1 minus 0.7, which is nothing but 0.3, right? Now we will move on to the test statistics. So your test statistics is Z is equal to P minus capital P divided by square root of PQ divided by N. So what is your small p? It is 0.65 and your capital P is 0.7 and the divided by square root of 0.7 into 0.3 divided by 100. Okay, so when you do this, this will be something like 0. So the value for this is nothing but 1.09. It will be minus because this is greater, right? Now take modulus of Z. When you take modulus of Z, it will be 1.09. Now, if you look at this, what did they ask us? Whether the what was the question? What is an appropriate conclusion? Test whether the actual proportion of products passing quality control is different. So, which means that your H0 is P, capital P is equal to 0.7 and your H1 is capital P not equal to 0.7, right? So now you compare, now your what it is not equal to, so which means that it is a two-tail test, because in the question we don't have something like superior, inferior, maximum, minimum, nothing is being mentioned, so it is a two-tail test. So for two-tailed test, for 5% it is 1.96. 1.96. So this is your table value and this is your calculated value. So now when you compare these two, your calculated value is less than the table value. So which means that what you are doing, you are accepting your H0. So you are accepting your H0 means which will come? Fail to reject the null hypothesis. Okay, fail to reject means what you are doing? You are accepting your null hypothesis. So that is the meaning of it. Now we'll move on to the next problem. A researcher wants to know if there is a significant difference in the proportion of smokers between two cities. A survey is conducted in city A and city B. So if you take city A, and city B. So if you take city A, what is your P1? 120 divided by 500. So out of 120, 500s are smokers. In city B, it is your sample proportion is 150 divided by 600. So what's the meaning of this? Out of 600, 150 are smokers. Now what you have to do, you have to test at 5% level whether there is a significant difference in the proportion of smokers between the two cities. So first step is, usually what you will do is, you will set up your null hypothesis, which is nothing but H0 from P1 is equal to P2. Is equal to P2, and your alternative hypothesis for this is P1 not equal to P2, because we are not asking something like who is superior than the other or inferior or maximum, minimum. All these things are not mentioned, just they have asked us to find the significant difference in the proportions. So your H0 is over, H1 is over. Now next one is your second step is nothing but the level of significance. It is given as 5%. So alpha is equal to 5%. That is given to us. And the third step is you have to compute the test statistics. So your test statistics is Z is equal to P1 minus P2 divided by square root of PQ into 1 by N1 plus 1 by N2. right? So now what you have to do is you have to calculate your P. So P is nothing but what? N1 P1 plus N2 P2 divided by N1 plus N2. So substitute your N1 value, P1 value, N2 value, P2, N1, N2. So all these values when you substitute, it will be equal to 0.25. So definitely your Q is 1 minus P, which is nothing but 0.75. Now what you have to do, all these values should be substituted in Z. So when you substitute in Z, you will be getting 1 point, not 1 point, it is 0 point something like 38 you will be getting. So this is your calculated value. Now fourth step is nothing but your table value. So table value for two-tailed test, this is two-tailed test. For 5% is nothing but table value is 1.96. Now compare the step 3 and step 4. So step 4, if you see that the table value is greater than the calculated value, so your decision is table value is greater than the calculated value, so which means that you are accepting your null hypothesis. So which means that fail to reject the null hypothesis, which means that you are accepting your null hypothesis. Okay. So this is the end of the session 1.